Yeah, hello everyone. Hopefully, I'm audible to everyone. Yeah, it's fine. Hi everyone. Welcome to the class. So let's wait for another 2 or 3 minutes, then we'll start the class. Thank you. It's already 6:02. We can start the class, I think. And I am sharing my screen. Sorry, sir. I think I stopped sharing. Sorry for getting shared. 1 minute. Let me check it once. Okay. Everything is fine. Okay, hi everyone. I think this one was last second last class. I think 29th people having exam. So, so if you have any doubt regarding exams, and you can ask me in this session, and I'll also check that if people have posted any questions. I think I have skipped this that session only. Yeah, in the next class is the last class, so I'll check those questions and ask to corresponding professors, and I make your doubts. I'll clear those doubts. Okay, I think that's from my side only. If you have questions, then you keep posting there. I'll check that, and in the next class I'll clarify them. Okay, let's start today's class. Hopefully my voice is audible to everyone. But today's class, based on the previous lectures, the organic chemistry, stereochemistry class. So here we will solve few doubts and solve few questions papers. Those are came in various competitive exam like NET, GATE. So I think that will be helpful for all of you. Okay, let's start today's class. So the first question today's the first question is the correct. This question came in 2022. I think this February some net was there that time this question came. Question was like that: between two faces, the correct relationship between two faces of the carbonyl group compound A and B. I will give two compounds because they are given two compounds, and we have to find that what is the relation between the two faces of carbonate. First, I will explain this thing. What does it mean by? I think if people asked very many questions in that portal, I'll check that thing. Okay, sorry, I couldn't able to do that thing, but next week I'll clarify those doubts. These are the options also I should write. They gave these options: A. Diastereotopic, B. Enantiotopic. A and B both enantiotopic. A enantiotopic, B diastereotopic. Another option was A and B both diastereotopic. So how to solve this question? First, does it mean by that phases? I think that concept I should introduce first. First, let us consider a planar molecule, means carbonyl. They in this, so I am just taking one mimic of this the molecule they have provided. They told to calculate means define the phases of the carbon. So for what does it mean by phases? Here the carbon in this molecule is a this carbon is sp2 hybridized, so this is a planar molecule. So let us consider that this molecule is in the plane of my screen. So we can see from the above the screen and below the screen. So these two are phases. Okay. So if some nucleophile I am telling nucleophile because the carbonyl center is slightly positive in nature, so nucleophile will try to attack there. So if nucleophile attacks there, means I am just giving one example. Then it can attack from the above face or the below face, two face. So we'll get two different products. That's why they are asking that why means two faces, because actually they wanted to know what is the stereochemistry of the products. That's why they asked what will be the stereochemistry of the two faces. It gives that product, means if it is diastereotopic the faces, then it will give two diastereomers. If it is enantiotopic the two faces, then the product will be enantiomers of each other. Okay, so they indirectly ask this question: what is the relation between the two faces? To actually know what is the stereochemistry of the product, if some nucleophile attacks there, it means attacks in the carbon. Okay, so for the things, so to how to solve this question. So few concepts you have to know before solving this question. First, what we all know that there are three types of homotopic, diastereotopic, and enantiotopic. When it will be homotopic, if any chiral means any sorry, if any excess of symmetry is present, means if any excess of, let us consider this molecule, excess of symmetry is present, then it will be then the two faces will be in homotopic. And then we will see any chiral center is present or blunt. Let us I'm giving one example. Okay, so if let's see what is called by chiral center. If four different here carbon can coordinate with, means at a sorry coordinate way, it can make the bond with four. It can then sorry fine. Okay, here we can see that this group, this group, this group, these two, four different groups. It's attached with four different groups. So it's a chiral center. Okay. So here it's a chiral center, and if a nucleophile attacks here, then it will form. Let us consider the chiral means every chiral center having some name means R or S. So I already discussed these things on the in the lectures. So let us consider. I'm just assuming this one is R configuration. Okay, this one is R configuration. I'm assuming. Then when the nucleophile attack here, it will form means. Let me write it here. I will write. Then I think it will be better to understand. Nucleophile attacks from the above above of the plane. It in this product and another product. These two products will form 1 minute. Okay, I think to confirm something. So, what is the relationship between these? Okay, let me first see that four different groups are attached. This group, this group, this group, this group. These four are different. So it will create another chiral center. So if we say the configuration of, I'm just assuming, okay, its configuration is this one is R and this one is R. Or you can also calculate what is the configuration from the Fisher projection. You have to draw it in the Fisher projection, but only to understand what is the relation. It's not mandatory to know the actual means nomenclature. So this chirality doesn't change after reaction. This is R. So here if it is R, then it will be S, because now it is in the above, it is in the below. So R, what is the RR and SR? So we can say that these are diastereomers. If they are enantiomer, then R is reflection RS, because they are mirror image. Then for being enantiomers, they have to mirror image of each other. So then the enantiomers of RS molecule will be SR. So these two are now diastereomers of each other. You can do in another way also. You have to transfer it in the Fisher projection. Then you can also see that there no mirror plane is there. So then you can tell that any plane of symmetry is not there. Then you can tell that this is the diastereomers of each other. But this is the means if you want to means solve it in a minute, or these are the tricks actually you can apply for competitive exams. Then another thing, if no any chiral center is there, then how to solve it? First, we have to make the reaction, perform the reaction, and have to analyze. Okay, have to analyze. First, you will see that if the reaction gives any enantiomer, this is this is the case where non chiral center is present previously, means before the reaction. Okay. Then you have to see that if it can generate a chiral center. Generates a chiral center, then it will give these two isomers will be enantiomers. How I am telling that you can also take one example and solve it. How I do, I am just telling that see if any you are giving these two nucleophile or H, these two products will form. Okay. So this nomenclature maybe if R, then it will be S, R and S. They are enantiomers of mirror image of each other, so they are enantiomers of each other. You can also do it in transferring it in the Fisher projection and on Newman, whatever you are comfortable with. Then you have to do the transformation, means that mirror image things, and that any symmetry is present, or that these things you can also perform if, if that is comfortable to you. And another thing is generates a chiral center or where no generation of the chiral center. Then we have to check, means what will be the possibility. This is the concept. Okay, now I will solve the question how they provided two molecule. Now I am coming back to the question. Question was like that. Sorry, my bad handwriting. OM, OM. Okay, now we'll see first. It's. So now see with this carbon, this group, this group, this group, and this group is not same. This group are different. So four different groups are there. So this is the one chiral center. Here you can see this group and this group are not equal. So four different groups are. This is another chiral center. Okay, two chiral center is already present. Now if I already told, you can easily solve it. You can, I think you already understood what will be the answer. I already told you if any chiral center is present, then it will make that isomers. You can also assume like that if these two are R, it will form S. R, R, R. Means only these centers stereochemistry will change, not these centers. So this center is constant. So what is the relation between these two? These are the diastereomers. You can add another. This is the simple way to do that. Actually, I don't know if it is R or SS. I'm just assuming they are the two different. If you see that, if I see that this is, if you tell me, if you just tell me here, ma'am, you are taking two R, so it's giving diastereomer. Okay, you can tell me if I'm taking R, this is the S. Okay, it doesn't matter actually. This stereochemistry will only change. This part will be constant. So it anyway it will be diastereomers. Now this so sorry. Okay. So my pen I am not reading it. Okay, and next another question was, I think CH3 was there. Okay, now we see first what thing. First here I told to, I forgot to tell you. First you have to check the any symmetry axis is normal. Here no symmetry axis there. No axis of symmetry. First here you have to see that any symmetry axis is there. No symmetry is there. No axis of symmetry. Now the second thing what We'll go step by step. Second thing, what I told to see any chiral center is there. So by looking, we can say that this is chiral center, but let's think that it is chiral center or not. Here you can see that this group and this group, both these groups are equal, same. Sorry, not equal. Are same. So what we can say that if two groups are same, so these two groups are different. So it is not a chiral center. If not a chiral center, now go back to the what things I provided you. First, we have to check that any axis of symmetry is there. No axis of symmetry is there. This possibility gone. Now this it doesn't have any chiral center also, so it can't be diastereomers. So the next thing what we have to check whether it generates a chiral center or not. This if it attacks nucleophile attacks from here or here, bottom or up, it will generate to it will generate a chiral center. How? This group and this group, this group and this group. These two are different, no? So it will generate a chiral center. Generating also it will be an topic. So topic faces are an topic in nature and the products will forms will be enantiomers of each other. Hopefully this okay. Hopefully you people understand these things because this type of questions are common in every whatever exam you will give in this type of questions. You have to make your concept clear for solving these questions. The next question I am moving. Okay, I am okay. This is also a very important thing. Before going to that question, I am this is trying to solve. This is also a competitive exam question. I think net question. They provided these three molecules. They wanted to know what is the relation between. Sorry, they wanted to know that which one will be the active, optically active. Sorry, optically active. So, okay, optically active. Okay, first, what thing we have to check? First, first thing, any chiral center is there or not. First thing is so first this thing you can see for different groups are attached. So this is the chiral center. So here you can in sulfur also you can see that sulfur 1, 2, 3, 4 lone pair. You have to consider lone pair also as sulfur makes 4 bonds. These things you have to consider. You have to look carefully actually how many bonds it can form, and you have to consider all the things. Here you can see that nitrogen is positively charged. If nitrogen is neutral, then it can form the 3 bonds. If it is positively charged, means it is making 4 bonds. Then you have to consider these 4 bonds. And if groups are different, then only you can say that this is the chiral center. So these two, I already got that these two are optically active. Now we have to see that this one is optically active now or not. This you can solve by. I think this you can easily solve. You have to just transfer it into Newman or Fisher projection formula. Then you have to check in any chiral, if any symmetry is there or not. Okay, these two groups. Okay, sorry. OH is below OH. You can also draw it in another manner also, no problem. I usually like this manner, so I'm writing it this way. means fissure also you can do. Now, what the things I will rotate 180 degree, and we know that 180 degree rotation doesn't change the symmetry of the molecule. We rotate 180 degree. So we can see 180 degree rotation. Let's change. You can see that here plane is there, mirror plane is there. So it's not optically active. So what will be the answer? These two are this one and these two are the optically active. If A, B, and C, then A and C will be the sorry A and C will be the answer. Now I am going to solve these questions are very important. How to say that? Means if you want to know the stereochemistry, you have to be smart means in this place because you go anywhere these type of questions will always they will ask. So means I am not solve. I can't solve 100 questions, but I can solve few questions so that you can get some knowledge that how to solve these questions. And this will be very helpful to solve your assignments also. Okay. So first we have to. They ask that what is the relation between HA, HB and HA, HC or HB. Okay. Now how to solve this question? First thing, please listen it clear. Okay, sorry. You have to first thing you have to do that you have to check any means axis of symmetry is there or not. This is the first question. Okay, let me write it. Otherwise, you people will forget it. First thing we have to find any axis of symmetry is there or not. So like these questions, this first let's see any axis of symmetry is there or not. You can easily say that this molecule doesn't have. So this molecule doesn't have any axis of symmetry. Now, for solving this kind of molecules, means this kind of especially for this kind of molecules, you have to this is a different kind of. So you can also this is only the means chirality. If you check, then it will be complicated. Means if you go to the nomenclature and all these things, you can easily solve it by that. That if you see the consider chloride, okay, with respect to chloride, it is cis. This one and this one cis in nature, and this one and HBU trans in nature. So cis trans isomerism comes. Cis trans isomers are the diastereomers, geometrical isomers. No, so they are diastereomers. These things I think you people all know this that cis trans isomers are diastereomers. So we can easily say that HA and HB are diastereomers. Now for HA and HHC, this one trans with respect to this one, this is trans. Okay, this with respect to this one, this is cis. So HA and HC or HB and CHC all are diastereomers because if you change that, if you make one thing constant, that it can it's showing that cis trans isomerism. This is a very important thing. You have to consider this thing. Then you can easily solve it easily. I will give another example also. If you, I think it may create a lot of doubts because you can many questions come into your mind. Any symmetry is there? Okay, I am solving this question. I think it will be helpful. Okay, for I think this is a similar case like the before. HA and HB. This one is the cis and this one is a trans. So they are also diastereomers. I think this will be helpful. This is a molecule. This kind of question usually comes. People usually ask this question. Okay, first, okay, HA and HC relation with respect to chloride. Now, first thing what we have to know, any symmetry axis is there or not. First thing, this is the main important thing. First, you have to look for it that any symmetry axis is there or not. First, you see if plane goes through it, means bisects it. You can easily see that there is a mirror plane goes through this. I think it's understandable. This is the okay. It means use different color. I think these two are chloride and this one the hydrogen. Okay, now mirror plane is there, so you can see that if mirror plane is there, then there will be diastereomers. So HC and HA, HC and HA, they are they are enantiomers of each other. And HB and HD, they are enantiomers of each other. And this plane is passing through this ClH bond. So this H and this HC, they will be diastereomers of each other. Okay. I think and before solving this, I should tell you some another thing. Okay, if some rules are there, if mirror plane, let me write it here. Okay, mirror plane bisecting, then there will be diastereomers. If bisecting two atoms, and if it's passing, making divided into two things, you can see then this plane divided these two things. So then it will be an topic. Enantiomers. So HC and HB are enantiomers, and HB and HD are the enantiomers of enantiomers of each other. And if someone asks HC and HD, then you can easily solve it by this way, no? With respect to chloride, it is Cs and Acs trans, so it will the HC and HD will be diastereomers of each other. Diastereomers of each other. I think you got it. How to solve this kind of questions. Okay, another question I am giving. These are all the competitive exam question. I am not HA, HP, HC, HD. And here for the things first I told you have to look for the axis of symmetry. Okay, here if you see that if there is an axis of symmetry, then you will get the identical structure. So these all the hydrogens will be homotopic in nature. I'm just showing one example how to solve these questions of every kind. This I first I gave diastereomers and this is the enantiomers and this is the homotopic homomers. So this kind of question. Okay. Another question I think this one the think this will also help you to better understand these things. Another question. Okay. It's a HP and HC. Okay. First step, for the things we have to see that if any C2 axis is there or not. So C2 axis, if C2 axis will be there, then it will be it should give it should be below. CS3 one CS should be above and below, so that if you rotate through this, then you should get the identical structure. But here you are not getting. So sorry, let me erase it. Okay, otherwise don't understand. Okay, so no C2 axis is there. Explain in axis of C2. Now next thing, if you carefully look, okay, I will see another color. I think that will be better to understand. If mirror plane, mine is not working. Okay, if mirror plane goes through it, okay, then you can see these two parts are similar. So it having a mirror plane. Mirror plane is there. If mirror plane is there and it divided into two parts, I already told you this HC and HT will be an anisotropic. And what I told previously, if it bisects these two things, then they will be diastereotropic. So what will be the relation between HA and HB? They will be stereotropic. Stereotropic. Why you feel the disturbance? I think some power cut happened here. Okay, I think that's all for today. Mm, some that happened there. So I am stopping the. Sorry, I am finishing the class for today, and we'll meet in the next class. And I'll also solve those questions you have asked me in that. Um, mm, Okay, those questions if people have asked in that portal, NPTEL portal, I will look that and I will ask to the sir and I will solve all the things before your exam in the next class. Okay, so be present in that class, and if you have any doubt, you can ask and you can make yourself clarify this because this is the last class. Next week, the next week class is the last class, and those if you have any doubt, you can ask in that class. So it will be helpful for your examination. I think it's on 29th. So that's all for my side. Okay. Okay, we'll meet in the next class, and I will talk to Sir about all these questions and give a clarification of these questions in the next class. Okay, for today I am finishing the class here. Okay. Let's meet in the next class. Okay, see you guys. Bye.